Hi everyone, this is lesson 6.3 on linear functions, and our goal today is to revisit linear functions and to learn about some additional concepts that will make working with linear functions easier. Alright, so basically what we're looking at is what we did in the last section of the chapter, which is being able to go back and forth between different representations of functions. Like for example, this is one I'm hoping is somewhat review. That if I'm thinking about slope-intercept, that I should be able to take this graph and change it into slope-intercept form of an equation. All right, and so just a refresher, one of the things we would need here, of course, is the y-intercept. If you look here, our y-intercept is 1, 2, 3, 4, 5, 6. So if we think about slope-intercept, which is this format, y equals mx plus b, that b would be the y-intercept, and we can put 6. Then, of course, we need slope. Slope is the number next to x, and so if we pick a point, maybe this one right here, it looks like we have to go down 2 and to the right 3. So down 2 would be negative 2, to the right would be positive 3. So that would give us a slope of negative 2 over 3x. All right, so this is what we're going to work on when it comes to linear equations. If it's a linear function, we're just practicing more about going from the different formats, graph to equations and all the rest. All right, now, this next example, we're going to start adding a few things in. Take a look here. Let's say I want to go from the table to the equation. And we know that this table just is listing 4 ordered pairs. So from what we learned in chapter 4, probably what we could do here is point slope form. So I could take these 2 points, 1, 2, and 3, 10. And then if you remember, we learned some stuff about using point slope form, okay, where you find the slope, y2 minus y1, x2 minus x1, you find the slope. Then we do that whole long point slope equation. Okay, but we're actually going to show you something different. So this is new. We don't actually need this. We're going to do slope-intercept again. We're going to do y equals mx plus b. Okay, and the first thing we're going to do is find slope. Okay, and all I'm going to do is I'm going to do a visual version of the slope formula. y2 minus y1 over x2 minus x1, which basically finds the jump in the rise numbers and the jump in the run numbers. So a different way to do that with the table, which we're just going to show you, this is new, this is something I want you to pick up on, is that we can just look at the table. These coordinates tell us by how much the y value is going to jump. So if I just look here and I just visually look 2 to 10, well, that's a jump of plus 8. From 10 to 14, that's a jump of plus 4. From 14 to 26, that's a jump of positive 12. Now x controls a cross movement, so this would give us our run numbers. If I look at those jumps, here I've got plus 2, here I've got plus 1, and here I've got plus 3. And what I can do, even though they're all different numbers, if I pair them together, so this top one, rise number is 8, the run number is 2, so the slope would be 8 over 2. If I do the second one, rise of 4 and a run of 1, or I can do the last one, 12 and 3. So rise of 12, run of 3. But no matter which one I pick, if you take a look, these are all equivalent fractions. These all reduce down to 4 over 1, or just 4. Okay, so this is another way to find slope, and we're basically doing the slope formula, but we're just doing it in a more visual way, straight off the table. So this is one skill I'd like you to master when it comes to linear functions. All right, so now I can go to my equation, and we've got a part of it. Y equals 4x plus b. All right, now, we still need b. We still need the y-intercept. Okay, it would have been nicer if it was listed here, but it isn't. Okay, so here's, again, something new, a way to use slope-intercept to find this number b. All right, what you can do is this. I have all these different possible selections for x and y. 1 and 2, 3 and 10, 4 and 14, 7 and 26. Pick one of them. I'm going to pick the easiest one. I'm going to pick 1 and 2. So to find b, what you can do is this. You can take your x value of 1 and plug it in. So 4 times 1. You can take your y value of 2, plug it in there. And by filling in the rest of the slope-intercept equation, we're down to one variable which we can solve for. 2 equals 4 times 1, which is 4, plus b. If I subtract 4 from both sides, 2 minus 4, that's negative 2, equals b. So there's my y-intercept. I didn't have to use 1, 2. I could have used any of these other points, and they still would have given me a y-intercept of negative 2. So now I've got all the pieces of my equation. If I go back, my equation is y equals the slope of 4 times x, and our y-intercept we just figured out, which is a negative or minus 2. All right, so this is something we're going to practice. We're going to work on going from the table to the equation, but we're not going to do point slope or standard. We're going to try to use slope-intercept for everything. Okay, it's just a different way to do some of the things that we learned in Chapter 4. All right, so let's see another example, because one time's not enough. So let's try that again. We're going to use slope-intercept, y equals mx plus b, and we're going to find the slope, and we're going to find the y-intercept without any other formulas. All right, so first step, let's find the slope. Let's look at the rise numbers and how they jump. Here they jump by 5. Looks like these all jump by 5. So this one's a little more of a straightforward example. And on this side, the run numbers, because x again controls a cross movement, goes by 2s. So that means that really doesn't matter which one I pick. The rise number's 5, the run number's 2, so my slope is 5 over 2. All right, so let's fill that in. Y equals 5 over 2x. All right, we still need the y-intercept though. Okay, if they had listed x is 0, y is something, we could just pull it from the table, but they didn't. So now what we do is we pick any of these. Now normally I pick the smallest numbers, but just for argument's sake, I'm going to pick one that's a different one, just so you can see that it won't matter. Let's say I pick this one. 9 is x, 26 is y. Just going to plug it into what I've got so far. So y is 26 equals 5 halves times x, which is 9, plus b. 5 times 9 is 45. 45 divided by 2 is 22 and a half. Subtract 22 and a half from both sides, and that'll turn out to be 3 and a half. So there's our y-intercept. So now I've got my slope, I've got my y-intercept, so now I just got to go back and plug this in right here. And so the equation that goes with this table equals y equals 5 halves x plus 3 and a half. All right, so this is a much faster way of going from the table to the equation, rather than what we've done in the past where you just kind of had to guess and check and try to see the connection between the inputs and the outputs. That when it's a linear function, that this is another way that we can come up with the equation without having to guess and check, and we've got a more systematic way of doing things. All right.